Well, hi guys, I'm back. It's been quite a while, so I'm gonna try my best. It's trying to remember how to do videos and run this camera, so we'll try our best. But before I get started here, I'll let you kind of look at what I got on the screen, and I'll talk about it here in a minute. Before I get to that, I just want to say thank you to all of those who replied and sent the well wishing in the comments and everything on my last video that talked about me being out for a while and stuff. It was greatly appreciated. I was overwhelmed by it. So I just wanted to say thank you. I want to say that you guys out there are that view my channel, that subscribe to my channel, watch my videos. I think you're the best out there. So thanks again, guys, and hopefully we'll get back on track here. I've got a lot of stuff to show you, a lot of stuff to talk about. Might have not been on YouTube much, or at least not making any videos, but I have not been idle. So anyway, so now to what we got here. And I'm hoping that this is coming in fairly decent. But this is a B&K Precision Model 177 VTVM. I picked this up here a few months ago. Pretty darn reasonable. It's in pretty darn good shape. You can see it from the front. Hopefully you can see it good enough. We have the top here. Nice tilt bracket and handle. All the feet are there. Not any scratches in it that I can find. Now there are a couple little minor blemishes that probably will never show up on the camera. There appears to be like a little bit of a chip right on this corner, and if the light's just right, there's a speck of dirt inside the plastic lens. So it's on the inside and not the outside. It came with the probes. First you got your ground probe. Just a banana jack alligator clip on the end. And then we've got the positive probe, which is in real good shape. B&K Dynascan. It's got the switch for DC and AC ohms. It's a standard for a lot of VTVMs, the probes. When you flip it to DC, it flips a 1 meg resistor in place, and then when you're back to AC ohms, it's for measuring AC or resistance. It's a direct shot. Now it does need some minor calibration. It's well within its calibration as far as adjustments go. I haven't got around to it, but I have tested it. The ohm scale seems to be pretty darn accurate, but the DC voltage, the AC voltage is close. The DC voltage on every scale, no matter what I'm measuring, at least lower voltage anyway, is about 1 volt low, it reads. So, and that'll be, there's you take the case, the back of the case off, and there's some adjustments for that, and that's easy enough to do. I do have the manual for it. It came in the original box, and I managed to put the manual up where I wouldn't lose it, and now I can't find it. So I did go online and print another one off, or scan one, get one off the internet, because I wanted to talk about one thing about this and kind of show you in the schematic of it. Most of the time you buy a VTVM off the, off of eBay or wherever you get one at, most of them will have a battery for the ohm scale, for your resistance. And it's a good idea to go ahead and pull it apart, look at that battery. It could be leaking, it could be just fine, it could be dead, or any number of other things about it. So every one I usually get, that's one thing I do, is just check the battery and make sure if it's leaky, get it out of there and start trying to clean up the battery acid that came from the battery and get it all cleaned up and get it neutralized, and then clean up the corrosion. But this does not use a battery. Instead, what it uses is it takes the tap off the 6.3 filament winding that goes to the two tubes in it, and it takes that, rectifies it, filters it, and uses it for the ohm scale. So the schematic printed out in two pieces here, so I'll try to get something to circle it and show it to you. I'll get a highlighter here. So on one half schematic, hold this, we have a power transformer, and down here you got, it says green and ground. You got a little X. This is your filament lead. One side goes to the ground. I guess they're both green. One side goes to ground, the other side feeds off to the tubes. On the other half of the schematic here, one spot it goes to is right here. You got D2, a little diode, and a 1510 volt capacitor right here that's going off to ground, filtering it, and then that feeds up to our range switch for checking our resistance. So there's no battery in it. Now, not much else to say about it. It's in good shape. Like I said, been well taken care of. There's another piece of equipment that I'll show in the next video that I got from the same place, which is an ICO oscilloscope, which was in its original box with all the paperwork too. But the main thing I want to talk on this video about a little bit more about VTVMs and old VOMs, or even certain digital meters. Now most people, or some people, will buy, something like this Fluke, or or some digital meter like this to use, which is auto ranging. You only got a few settings on the switch and it just pops up, and it's auto ranging, which means what it does is whatever, as long as you're within the limits of the meter, not going way over voltage on it, you set it, whatever you measure, it will automatically range out and give you a correct reading. So if you flip it to DC volts and you go first measure maybe a B plus voltage, say 250 volts, it'll give you 250 volts DC showing on here. And then you go over and you measure, say, a negative grid voltage. Say it's somewhere around 5 volts. It'll give you a negative 5 volts on here without having to move the knob at all. VTVMs, on the other hand, and I'm going to see if I can kind of zoom in on this a little bit, if possible, without losing focus. They have ranges. Now hopefully you can see that. It starts at 0.5 volts, 1.5 volt, 5 volt, 15 volt, 50 volt, 150 volt, 500 volt, and 1500 volts. Most of them range from at least 1.5 to 1500. Some do have a low voltage scale, but there'll be something towards that effect that you'll find. And there are digital meters you can buy that you have to find the range. You have to switch it. It's not auto ranging. Well, I have read and not so much comments in my videos, but other people's videos, also in the forums and other places. People seem to get a little confused about these ranges. So I wanted to kind of explain a little bit about them. And see if I can kind of just take this up just a little bit. Okay. And the biggest question is, more than anything else, is what range do I set it on? Well, there's actually two answers to that. The first answer, if you know pretty good sure, you got a schematic, service information that's telling you what voltage should be at a certain point, maybe a certain pin number on a tube, or somewhere on the schematic it's showing a voltage on there. So if you know the voltage that you should be seeing or looking for, then you want to set the range so it's the closest to that voltage, but above it. You want to be above it. Now, the first thing you need to understand is these different ranges, 15, 50, 150, and so on, is full scale. So, say the 150 volt scale, we'd use, it says DC or RMS AC. We'd use something that has a 15 in it, which is this 0 to 1.5. And we'd just take it times 100. And that'd give us 150 volts full scale. So if I wanted to measure, say, something that's 100 volts DC, well, the low scale below that is 50 volts. That's too low. I'd want to set it for 150. The meter would then come up to the 1.0 here. Take that times 100. That's 100 volts. So basically, if you was reading something that's going to be like, say, 400 volts, well, you want to set it on the 500 volt scale. That'd be this 0 through 5 scale up here. And it would read right here. Because the full scale is 500. All these are times 100, so this would be with the 400 volts. So the simple answer, the first answer, if you know the voltage, set it to the scale or the range that's the closest to your voltage, but above it. Full scale above it. Otherwise, you're going to peg the meter. Now, the electronics in here can handle it, but if you slam that needle too hard, it will bend it, or it could even break it. So you don't want to peg it real hard. Now, the other part of the answer is, what if you don't know for sure what the voltage is? Maybe you're measuring an unknown transformer and wanting to check the voltages on it. Maybe you're going to build something. You got this in your junk box, or any number of things. Or maybe you just don't have any service information at all. Well, then you want, the safest bet is always set it to your highest scale. Then if it's reading way down in this area, down here, then you can move it down the next scale until you can kind of get up in here someplace where it's easier to read. But always, when you don't know the voltage, set your maximum scale. That way the meter itself, the meter movement is well protected, and you don't have to worry about banging the needle. Of course, you do need to have some idea what it is, only for the standpoint that you're not measuring something that has like, might plug in the wall and have 10,000 volts off of it, so, or 5,000 or something like that. That would not be good. But that's basically the answer to the question. Your scale is full scale on these voltages. So whatever range you set it to is full scale. You pick out the scale from what it says on the meter. Pretty much all DC and RMS voltages are measured on these two scales here. Either the 0 to 1.5 or the 0 to 5. And you just multiply them times whatever factor that whatever the scale is, or range you set it on. Now low voltages, this is low AC, RMS is down here, and then the red is just your peak to peak voltages, which is red underneath. That's these kind of yellow colored. Now each meter is a little bit different, so you want to kind of look at it and kind of get a feel of it. Take some known voltage measurements to get a feel. So, but if there's more questions on this, if you want a more elaborate something done on this, just leave in the comments, and we'll do another video and try to get a little more closer on it. I might show some other meters I've got, some VOMs and stuff like that. I do not have a digital meter that you set the ranges on, but it'll be very similar to a switch like this, except might have a lot more to it, you know, more numbers, more ranges possibly. But I can go over it a little more in more detail, maybe get a better video of it or something, and hopefully you can see it better. I'm pretty sure it's, I don't know, I'm looking through the little LCD monitor. It's on the back and it's small, and it looks like everything's in focus. So anyway, what's for the future? Well, some of the future videos coming out is showing you some more stuff I've got. I ended up buying some 25 radios over the last few months, various different years and makes and models, plus 3 TVs and some other stuff, well, the meter and some other test equipment. So we'll be talking about those. Some other things is going over a schematic, how to read a schematic, but more importantly, how to follow a schematic, and so that you can get a feel of it and stuff. So we'll do that, and some other future videos coming up soon will be a lot of times in service information you'll run into, especially SAMs, where it may have a voltage table where it lists the tubes and the pins and tells you each pin has this many volts on it and so on. But they also publish in all their SAMs a resistance table. It looks like the same thing, except it's resistance on each pin on each one of the tubes, and it's usually taken to ground, otherwise, unless it's stated somewhere in the notes to it. Most of the time when you run into these, the equipment you're working with is relatively non-complex, meaning it don't have a lot of circuitry that this is going through, that when you're checking a particular pin resistance. Most of the time it may be just either a transformer primary or just a single, maybe couple resistors that you're actually measuring. But I've got one that I want to show you, and I thought we'd go with the most something that's extremely complex, because you might run into it and you might get a, when you're doing one of your, on troubleshooting, the radio's not working right, and you're doing the resistance checks, and it don't come out right. It's off. It's either high or low, and you're trying to figure out why. Well, I'll show you how to go through a fairly complex circuit that has several resistors that's in parallel, in series parallel, and basically about 4 branches in this thing, and they all go together to create that one resistance reading. So anyway, that's a future video. So look forward to these videos. They'll probably be slow coming at first, and hopefully I don't sound too bad. I know I'm hoarse. I've been fighting a cold. And one of the things is stuffy nose, runny nose, and a cough. So anyway, thanks again for all your comments, and I want to thank all my new subscribers. I've been quite surprised how many new subscribers I've gotten, and so again, thank all of you. And if you like the video, give it a thumbs up, comment, and if you're not subscribed, might consider subscribing. Thanks again for listening and following with me, and I'll talk to you later.